Storms, cyclones are vicious but are really interesting from a mathematical perspective. Cyclones are basically low pressure areas surrounded by a high pressure region. In this video, we'll be discussing about mathematical model of wind disturbances creating a vortex which under favorable conditions can give rise to a cyclone. We will basically be discussing about nascent cyclones or the cyclones which have just started to develop but is not completely developed. The source article is written by Kaushik Kumar Majumdar. Link is in the description. Now, we know that cyclones are created due to disturbances. So we basically need to focus on the disturbances. To define them, we are going to use the cylindrical coordinate system. Here, a point is defined as the following. Take a point, drop a line from the point on the xy plane. Draw a radial vector from the origin to the point on the plane. Notice the angle between the vector and the x-axis. Let the length of the vector be r, the angle be theta, and let the z coordinate be z. It's like the polar coordinates but with a third dimension. We are assuming that the wind drag will be along a log spiral which is similar to that near the eye of a cyclone. Resolving the velocity of the disturbances, we get the following components of the cylindrical coordinates: the radial component, the cross-radial component, and the vertical component. Now, to get the log spiral, if we see the cyclone from the top, the following condition must satisfy. Further, we assume that the disturbances are parallel to the ground, therefore there is no disturbance along the vertical component. Now, a thing must be noted. These equations give a simple dynamical model of the disturbances leading to the development of a storm. Unfortunately, these equations are valid for a very short period of time, which is during the very beginning of the storm. The value of r basically depends on the value of theta, which is non-fuzzy, and the initial value of r. Now, what does non-fuzzy mean? Well, we will come back to it later. Now, in practice, the value of r0 can't be determined precisely. Besides, the value of m fluctuates even in short intervals. So the uncertainty in r is a compound uncertainty. So to deal with these uncertainties, we will use the concept of fuzzy numbers. Now, what actually is a fuzzy number? Suppose you are driving a car and there is another car moving in front of you. If you get near to that car in front, you will need to apply the brakes. Now, how to understand whether you are near or far from that car? It is really difficult to define a margin or a barrier. So instead, we define a scale of possible distances. Now, we can assign each point on the range a value which can give us an idea regarding how close we are to that car. These values lie between 0 and 1 and are called the membership values. So that's basically the concept of fuzzy numbers, where a variable does not have a discrete value but set of possible values with certain probabilities which are connected among each other. Now let's get back to storms. So to include the uncertainties, we frame this relation. Now this and this are the alpha level subset of the fuzzy sets. Now what's that? First, let's try to understand what is a fuzzy set. If mu is called a fuzzy set, then mu is simply a mapping from real numbers to closed interval of 0, 1 such that there exists a closed interval such that if x does not belong to it, mu of x is 0. A fuzzy set just gives the membership values to the set of possible values. Now, what is meant by possible values? Well, the possible values mean the values which have the capabilities to give rise to a storm. The fuzzy sets can look like this. The membership value of C is 1 here. It means that it can occur with 100% possibility. Similarly, for this case, values between C and D has probability 1 of occurrence. Now, what is an alpha level subset? It's basically a subset of the fuzzy set which contains those elements whose membership values are greater than alpha. We represent it like this. So this differential equation makes sense now. Here the constant m is also a fuzzy number. Here capital M is considered as trapezoidal fuzzy number and R0 is considered a triangular fuzzy number. Now all we need to do is to find a solution of the differential equation and assign each solution membership values and take those solutions whose membership value is greater than alpha. So at first we will replace the belongs to with equals so that it becomes an equation. Then we will fix an alpha which is between 0 and 1 and solve the equation. This will give us the plot when we take x and y as specified. The significance of the log spiral is that it represents the disturbances which, when strong enough, can give rise to cyclones. Now you might have a question. In the entire video I have been talking about assumptions like the values of A and B and other stuffs. Well, these informations are found out experimentally.